plus 49. Descending order, it's a trinomial. Greatest common factor, no. Negative leading coefficient, no. Special product, I always hope for a special product. I see this is a perfect square and this is a perfect square with plus. So I expect x plus 7 everything squared. But you should say not so fast because you have not checked the middle term. You cannot walk away from this and say, oh, this works. No. You must check the middle term. As you see, I didn't even look at it. I didn't even take it into account. So the middle term here is 2 times x times 7, which is 14x. If this is 14x, then I'll say yes. If this is not 14x, I have to cross it out. But it is 14x. That's what I'm saying. The special products are always the easiest, as long as you understand the pattern. Okay, so let's stop at any other problem that you want in the trinomial situation. If you want, we can work on this one. Yes? No? Okay. Good. So we have t squared plus 2/5 t and plus 1 over 25. Remember, nobody can force us to work with fractions. I'll find the least common denominator, which is 25. I'll multiply this by 25 and this by 5 and this by 1. 25t squared plus 10t and plus 1. And I will leave 1 over 25 outside. Descending order, greatest common factor, no. Negative leading coefficient, no. Special product, I always hope for a special product. This is my hope. Does it work? I don't know. I haven't checked the middle term. But the middle term here is 2 times the first term times the second, which is 10t. Yes. So I know that this is the correct factored form. As I mentioned, special products are always very straightforward, but you have to remember the strategy. If you do not go through the factoring strategy exactly in the order I asked you to, descending order, greatest common factor, negative leading coefficient, trinomial, special product, 1 is the leading coefficient, or not 1 is the leading coefficient, you're going to struggle, potentially. So please remember. Okay. Okay, so now they're moving us to a different special product. Fine. 9x squared minus 25. So what is it? Now you have to say a binomial. And we have 4 special products for binomials. So the strategy is this now. This one. Still descending order, yes. Greatest common factor, no. Negative leading coefficient, no. So now I follow this strategy. And I only see 2 possibilities here. One with a minus as a difference of squares, and one with a minus as a difference of cubes. Well, which one is it? Is it the difference of squares? If you say the difference of squares, then I have to come up with 2 binomials. But if you say the difference of cubes, then I have a binomial times a trinomial. And we have to decide which one it is. Is it a difference of squares, meaning 2 binomials, or a difference of cubes, meaning a binomial times a trinomial? Well, there is nothing I can cube to get this. So the difference of cubes is not applicable here. There is nothing I can cube to get 25. So the second option is basically not an option. Good. So then what do I use? If it's a difference of squares, I know I have to have the same thing. One with plus in between and one with minus in between. That's it. So What do you recommend? What do I square to get 9x squared? And what do I square? 3x and 5. Very good. This squared minus this squared. Again, this is not difficult, but it requires a lot of patience and a lot of work. And watching what we did today and in the last 2 weeks till you understand all the steps and you're able to apply them. Okay. Good. Let's look at this one. We had something similar last week. So a squared minus 1 over 16. Now let me copy a few of those. Okay, this is, okay, yes, let's also copy x squared plus 144 y squared. And let's see. What else? Yes, also 4x squared minus 144. Yes, 125 x cubed minus 64 y cubed. That's also a good one. Yep, why not? X cubed plus 125. 1 over 125. Good. Okay, we know how to, unless you, once you get to these problems, we can do them in class together on Thursday. Okay, so I think we got the idea. Good. So we have few examples to work on. Again, the same concept. It's a binomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product. Can anyone give us an idea about the special product? Of course, it's a difference of squares because I cannot cube anything to get a squared. I cannot cube anything to get 1 over 16. So it's a difference of squares. So what do I get? Anybody?
A and 1 over 4.
A and 1 over 4. So a plus 1/4, a minus 1/4 in any order you want. What about this one? It's a binomial. You can say descending order. Yeah, based on powers of x. That's fine. Greatest common factor, no. Negative leading coefficient, no. Special product, I always hope for a special product. Let's look at the special products we have for the binomial again, right here in the handout. So here they are. So this has a plus. So I can only have the sum of squares or the sum of cubes. But there is nothing I can cube to get x squared. So it can only be this. But what do we know about the sum of squares? Always. The sum of squares is the sum of squares
times itself?
not factorable. Exactly. If you want to say prime, I'll say prime. Perfect. Excellent. Good. Let's look at the next one. 4x squared minus 144. It's a binomial. It's in descending order. Greatest common factor? Yes. And I have to pull it out. If I don't, I make my life more difficult. And it will not be entirely correct. So what will you factor out from 4 and 144? Anybody? the greatest common factor is 4. What is left in parentheses? X squared minus 36. So now I'm asking myself, how do I factor this? And they are all the same. So it's the difference of squares. How do I factor x squared minus 36? Anybody, please?
X minus 6.
And x plus 6. Difference of squares. Very good. Good. So let's move on to the next one. Difference of two binomials. So it's a binomial, descending order, yes, based on powers of x. Greatest common factor, no. Negative leading coefficient, no. Special product, I always hope for a special product. So we go back to special products for binomials. And it's not a perfect square. And it's a difference. So it's the only one that I can apply, if it works. A cubed minus b cubed. So remember what we did. If it's a difference of cubes, I have to have a binomial and a trinomial. Once I identify the binomial, the trinomial will be easy. And remember the steps. We always start with the signs. If the binomial has minus, then the binomial will have minus and the trinomial will have plus. Of course, the last term is always plus. We don't even talk about it. Now I need to identify what do I cube to get this and what do I cube to get this. Can anyone give us an idea of what do we cube to get 125x cubed? What do we cube to get 125x cubed? What term do we cube to get 125x cubed? Please, anybody? And the same question for what do we cube to get 64y cubed? Anyone, please?
5.
Yes? 5x?
And 4.
4y. Very good. Now the trinomial is very easy. We square this, and we just multiply them without an extra 2. Square, square, multiply. Always set up the signs first. Minus, minus, plus. Then find which term you cube to get this, which term you cube to get this. And this will follow very easily. Square, square, multiply. Any questions? Okay. And one last one here. Same binomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. I hope for a special product. And let's look. These are the 4 special products. It's not the sum of squares. There is nothing I can square to get x cubed. So it must be the sum of cubes. Once we set the sum of cubes, we have to prepare a binomial times a trinomial. Good. The next step in the thinking process must be the sequence of signs. Now we have to identify which quantity we cube to get this and which quantity we cube to get this. And the rest will follow very easily.
X and 1/5.
X and 1/5. Once you said that, I square, multiply. and it's done. Okay, the next section is everything put together. So summary factoring techniques. We already know the factoring techniques. We will go through 6.5 on Thursday. I wanted to show you that, so we're going to look at equations right now. I wanted to show you that there is a test 3 class work and practice. This is what we're going to do next Thursday. Okay? Please start working on it. So allow me now to look at solving polynomial equations. This is very important. I need to explain. I'm just going to have it ready. Open up and let's talk about it. Factoring has a lot of applications. First application of factoring polynomials is solving equations. So here's an example. Before we look at the first example, actually, I just want to present something called the zero product principle. The zero product principle. The zero product principle says the following. If I have any number of factors, they are multiplied, not terms, factors, any number of factors, let's say 4 factors, set equal to 0, zero product principle. If I have 4 factors, then I have from here either A can be 0, or B can be 0, or C can be 0, or D can be 0. But I have to have this format. I have to have a product on one side, and I have to have 0 on the other. Otherwise, the zero product principle is not applicable. So here's our first example, and then we look at the examples in Pearson. Let's say I have x squared minus 2x equals 0. I have 0 on one side, but this is not a product. Not a product yet. So I need to factor. Well, it's about binomial, it's in descending order. Does it have a greatest common factor? Yes, it does. Which is what is the greatest common factor that it needs to be pulled out? The greatest common factor that needs to be pulled out, please.
X.
Indeed. What is left in parentheses? We started with the 2 terms. We need 2 terms in parentheses.
X minus 2.
X minus 2. So this left-hand side now is a product. It has 1 factor, and it has a second factor. So if the first factor is 0, x is 0. If the second factor is 0, x minus 2 is 0, which means x equals 2. So these are the 2 solutions of the equation x squared minus 2x equals 0. This makes sense because the degree is 2. So degree n implies n solutions. Even if they're all the same. Degree 2, I found 2 solutions. If I had degree 3, I will find 3 solutions. Real or imaginary. We haven't gotten to that yet. But regardless, we have to find the degree, and that will tell us how many solutions to expect. So let's practice the zero product principle. this is the last section, except the one with all of them put together, then we will review on Thursday. But please finish everything with 70%. The test is a week from today.